In this video, I will show you how to use the law of sines to solve an advanced word problem. To measure the height of Lincoln's face on Mount Rushmore, two sightings 800 feet from the base of the mountain are taken. If the angle of elevation to the bottom of Lincoln's face is 32 degrees and the angle of elevation to the top is 35 degrees, what is the height of Lincoln's face? Let's let this picture of Abe Lincoln represent his image on Mount Rushmore. So this whole picture, think of this as the mountain. So the base of the mountain the distance from the point of observation to the base of the mountain will be this green segment. So the problem says that the two sightings are both 800 feet from the base of the mountain. So the 800 feet is down here. So this is the 800 feet. Okay, the green segment from the point of observation to the base of the mountain. The angle of elevation to the bottom of Lincoln's face is 32 degrees. So that means that this is 32 degrees. And then the angle of elevation to the top of Lincoln's face is 35 degrees. So that means that this is 35 degrees. All right, obviously this drawing is not to scale. So one important thing to realize is that the angle right here where I just put this question mark, what is that going to be? Well, if the large angle is 35 degrees and the smaller angle is 32 degrees, the angle in between is going to be 3 degrees. So this angle right here is going to be 3 degrees. Let's start by finding as many angles as we can. For example, looking at the lower triangle, I see that we have the 32 degrees and we have 90 degrees. So that means that the other angle must be 58 degrees because the total degrees in the triangle has to add up to 180. So for example, if I do 180 minus 90 minus 32, that gives me 58 degrees. Or I could use a very small shortcut, which is that if I already know that one angle is 90 degrees, the other two angles have to add up to 90 degrees. So I really didn't need to do anything with 180. I could have simply done 90 minus 32. And that's going to be 58 degrees. So we know that this angle in the corner right here is going to be 58 degrees. What about the angle, the obtuse angle on the other side of the blue line? We should be able to find that as well because this yellow line is a straight angle. We should have a total of 180 degrees between these two angles. So in other words, if we do 180 minus 58, we find that this angle is 122 degrees. Now we have 122 degrees and 3 degrees. Together, that's a total of 125 degrees. So if I do 180 degrees minus 125 degrees, that leaves 55 degrees for this angle at the top. So this angle at the top is 55 degrees. So we really have all of the angles inside this picture. So next, let's find the length of the teal segment. Let's find the length of y. So I really want you to focus on just the bottom triangle. I'm going to do this in teal so it sort of matches what we're doing here. Well, you know what? I'm going to use this sea green color. So we're going to find the length of y. We don't need the law of sines yet. This is a right triangle down here. So if I want to find y, if I use the 32, I can simply use cosine. So the cosine of 32 degrees, remember cosine is adjacent over hypotenuse. So the cosine of 32 should be adjacent over hypotenuse. That's 800 over y. And we've learned that when the variable is in the bottom, in the denominator, we can swap these. So that's going to give us y equals 800 over cosine 32. So that is 943.34. And we are talking about feet. So that is the length of the blue line. That is the value of y. So maybe I will squeeze that in there. Okay, so I'm going to erase y. And let's see, I don't think I need this 35 anymore. Just trying to clean my picture up a little bit. So I'm going to squeeze that number in right there. So we just found that the length of y is this 943.34 feet. Now we can use the law of sines to solve for the thing that we really wanted to find in the first place, which was the height of Lincoln's face. Okay, so hopefully you can see this if I put it in orange. All right, the height of Lincoln's face goes from here to here. So this is the x for which we must solve. So now we are working on the upper triangle. This is not a right triangle, so I am going to need the law of sines. So I should be able to do x over, all right, since I'm looking for x, I'm going to put x in the top. In the denominator, I'm going to put the sine of 3 degrees. So x over the sine of 3. Okay. Now I need another side and angle pair. Well, I have this 943.34. That's another side. So I can put 943.34 over the sine, and the angle across from this is 55. So the sine of 55 degrees. So I will simply multiply both sides by the sine of 3. So if I multiply by the sine of 3 on the left and the right, that gets x by itself. Calculator time. So we are just putting everything on the right-hand side of the equation into the calculator. So 943.34 times the sine of 3. And that's all over the sine of 55. So I'm getting 60.27. So x is 60.27 feet. And that is the height of Lincoln's face on Mount Rushmore.